want to run through two of the most common types of saw blades that I use in my table saw and why I change them out. Here we have a more of a general purpose rip and cross cut blade, and I also have a more dedicated rip blade here. There are three main features that affects how the blade performs. The first one is the number of the teeth on the blade. The second one is the angle of the face of that tooth to the blade. And the third one is the bevel, which is the angle of the top of that little tooth. So with the number of teeth, in general, the more teeth you have, the cleaner the cut is going to be. But it also slows the cut down. So with rip blades, they generally have less teeth. This one has 30 teeth rather than 48. So that means it'll cut through the timber more quickly and is more suited to longer cuts ripping through the timber. So the next thing that affects performance is the angle of the tooth. So if we imagine a line drawn from the center of the blade out to the edge, the angle is actually the angle of the face of the tooth to that line. So in this case, this is a 13 degree, which puts the blade angle about there. And with the rip blade, it's a 20 degree, which is actually a much steeper angle. So if you imagine the angle from that center line, that's the 20 degree there. So the effect that this has on the performance is that the steeper angle of this rip blade actually pulls the wood more into the blade, and that creates a faster cut, but it can also affect the quality of the cut and it can make it a little bit rougher. If you're using really brittle materials like melamine or some of the other man-made chipboards and so forth, that really steep angle can actually have a really negative effect on the quality of the cut and can tear out a lot and shatter some of those fibres. So the last feature that I want to talk about is the bevel of the teeth. And the easiest way to describe this is if you're looking at the tooth from the front as you are now, each one of these two teeth has an angle on this particular blade and they alternate. This is called an alternating top bevel or an ATB blade. And so that means that this tooth goes this way, the next tooth goes this way, and it means that the whole way around they alternate and there's a really sharp point in contact with the timber at all times. So with this ripping blade, rather than having an alternating top bevel like that general purpose blade, each of these teeth is actually dead flat and they're all exactly the same. And so that means that it's going to cut out much bigger pieces each time and it's going to be a faster cut. But if you're trying to cross cut with this, it's essentially going to be bashing the timber on every single tooth. So it's not designed for cross cutting, and we'll give that a shot later and show how that works. The last difference between these blades that I want to talk about is the size of this gullet. Basically, because this blade, this ripping blade, is going to be cutting along the fibres, the pieces of wood that it's going to be cutting out are going to be long strands, they're going to be bigger chips, and so this larger gullet will allow for the clearance of those chips. With this blade, if you're going to be cross-cutting and you're cutting against the grain, each chip that you're pulling out is going to be much smaller, basically dust or tiny fibres, and so the gullet can be a lot smaller. So at a glance, you can tell the difference between these blades by looking at the size of those gullets. All of the Torquata blades are laser cut from high quality steel, and then they use high quality carbide teeth. One thing that is different about these blades, and is a really good function, is that there's a lot of meat, there's a lot of carbide on each tooth. And what that means is you actually can sharpen these blades quite a lot of times and get a lot of life out of them. It also, for some reason, makes the blades a little bit quieter. You'll also notice this fishhook feature, these little cuts on the edge of each of the blades, and that's on both the rip blades and the cross-cut blades. And that reduces any deformation or twisting of these blades as the heat expands this outer edge. It's a really important feature to keep your blades super flat. Alright, I'm going to throw this ripping blade on the machine and see how it works, and I'll go through some of the bits and pieces that you need to do when you're changing the blade. This blade has a 30mm arbor. The arbor on my saw is actually a 5/8, but it's got a 30mm shim in there, which means it'll fit perfectly. Those shims are cheap and they're available wherever you're going to buy your blades, like Timbecon. You've got to make sure the blade's going in the right direction. Table saw blades always spins towards you at the top, so in this case it puts the label forward. Put that on the shim, hard up against that metal plate. You've got this metal bushing which goes on next, and then you've got your nut. Gotta be careful, these blades are pretty sharp, but I'm holding it by the edge and it's working out fine. Okay, so I put the nut on, just making sure that that blade is sitting on the right up against the bushing on both sides, which it is. So right now it's just finger tight. What I do to tighten it up is I get one of these clamps. I put it just gently on the blade. I don't want to compress it too much so that I'm bending the blade, but that's going to stop the blade spinning. I get my spanner, put it on the nut. So that's a little tight. Okay. And I like to actually use a piece of PVC on the spanner, and this just keeps my hands away from the blade when I'm applying force, because it could be easy to slip and put a piece of carbide steel into your finger. Now, I don't want to do this too much. Ultimately, you just need to gauge how tight it needs to be. Okay, that's good to go. Obviously, all of this has to be done with your table saw unplugged, which should have been the first thing I said, but it has been unplugged the whole time. Alrighty, so before we use this, I've got to lower the blade right down because I brought it right up so that I could change it and get access to that bolt in the arbor. And then I've got to put this throat back in. And depending on your saw, you'll just have to figure out how to do that yourself. Alright, I'm all ready to go. I've got a scrap piece of hardwood here that I'm going to test this rip blade on. I've got the saw blade all set up and put on the safety gear. I've taken the guard off at the moment so that we can see with the cameras, but normally don't take your guard off. And I think we're ready to go. Alright, so that was a really nice, quick, clean cut. It's done exactly what it's meant to do. This is a pretty crummy old piece of timber and it had a bit of a twist in it, so got a little bit of biting there, but if the wood was straight to begin with, that wouldn't have happened. But no, that was very effective. Now that I've done that rip cut, I want to use this rip blade to do a cross cut in this piece of hardwood just to demonstrate what I was talking about with the way that those teeth are going to affect the quality of that cut. Safety gear as always. Alright, so it cut through it super quickly, but that cut is actually a bit rough and there was quite a fair bit of tear out on the back. And that's hopefully what we're going to avoid by using a more dedicated cross-cut or multi-purpose blade once I change that out. Alright, I've set this up to do a simple miter cut just to test again what this rip blade does when it's doing what it's not exactly designed for. Give that a shot now. Just a piece of Tassie oak with my homemade miter sled, ready to go. Okay, we've tested out that rip blade with a few different chunks of timber, and now I'm going to swap it over and test out my other blade. So take out the power, put the blade back to straight, lower it right down, take out the throat, swap it over, exactly the same thing in reverse. I'm going to do a quick rip with this cross-cut sort of multi-purpose blade and a couple other cross cuts, and then compare the quality of the cut with the other blade as well. Alright, so I've run through a bunch of different timbers with some different types of cuts with both the dedicated ripping blade and this more general purpose kind of cross-cut blade. It's pretty clear on all of the timbers that the ripping blade had a lot more tear out on the back edge as the saw was exiting the timber, and also on the face of the timber the ripping blade still cut well, but it's just a less smooth cut on the actual face than it was with the more multi-purpose cross-cut blade. And as you have a closer look, you'll see the tear out on each of these edges compared between the rip and the cross-cut blades. Alright, so I did both of those tests and I basically got the results that I expected. The ripping blade was a lot quicker for ripping and for cross-cutting actually, but the results, especially tear out on the back edge, were just not quite good enough. And if I was using really nice timbers and trying to create a really nice piece, I'd have to go through and fix every piece of that tear out, and sometimes you can't even fix it. So ultimately, you could possibly get away with one blade, but if you're trying to do really high quality work, it's just not quite acceptable for that level of tear out, and that's where a more multi-purpose blade or even a dedicated cross-cut blade really comes into its own. And it's worth a couple minutes to change them over because of the quality of the cut that you're going to get. You can pick up both of these blades as well as more specialised Torquata blades at Timbecon. You can grab them online at timbecon.com.au or in either of the stores in Perth and in Melbourne.